Welcome back to Coding Escape. Coding Game, Coding Escape. We are on to a pair of games called Castel, Sant'Angelo. They both seem shorter than the Sherlock ones I did last time, so this could be a shorter stream. But there are two of them. And like before, the deal is that we're in some sort of escape room and we've got to solve puzzles and we can use coding. But they can also be solved using logic as well, pen and paper, but I'll try and use coding where I can. And yeah, I'll just, before I start, let me just get my tea, and I forgot to get pen and paper as well. Alright, got some paper, in case I need it. Usually we don't. Because... Actually no, sometimes... Actually, we did last time, because it's like, there's puzzles where you need to copy down some things you see on the walls and stuff. Alright. Alright, let's begin then. Castel, Sant'Angelo. Entrance. Oh, let's read the blurb. You have been sent back in time to research the source of a pandemic that may wipe out humanity. It appears that there is some similarity between the virus strain and the one responsible for the pandemic called Justinian Plague in 560 AD. Studies have been conducted on this devastating virus and are kept in the secret archives of the Castel Sant'Angelo. Angelo? I think Angelo. There are rumors that monks were able to concoct a preparation from a plant which saved some parts of the population. You will take advantage of the castle being closed for renovations to get inside. The objective is to find the secret archives and recover these manuscripts to hopefully find some answers. First, you must enter the castle through the public entrance. A work of art is on display there, and it would be directly linked to the museum's opening system. We're counting on you. Good luck. This puzzle was released towards the end of 2020, so they were cashing in on the hot topic of the year. All right, let's go. Pandemics. All right, launch. There we go. All right, Python. All right. What have we got? Various things. Let's have a look at the top one. Artwork blocks. It is possible to retrieve the position of all the blocks of the top part of this artwork. So it's basically a grid with ones and zeros. Eight rows, 13 slots each, and a 1 for each block. Okay, that's the thing. Over here, another one. Here, another one. Here, another one. And then what's this? The blocks of this artwork can be moved to the bottom part. It is possible to modify the artwork and move the blocks to the desired position. So they want us to move... Oh, I see. So it's just basically the, like, the sum of these three. Sort of. Is that what they want us to do? Well, that should be... pretty easy. We can try that. So we would need... that as an input. That as an input. That as an input. Let me just have a look at this. Oh, we can't just look at it. Alright, fine. And then we want that as an output. No. That's an input. And that as an output. So it's 4 of these we need to sum together. An array of 8 rows, each containing 13 slots. Okay. Alright, so... the result equals... so it's going to be a... and then we've got 8 rows. So that's all zeros. And then we want to go for array in... so it'll be lines 2, lines 3, lines 4. Let's say for I in range 8, for j in range 13. If array ij is 1. What, are these numbers or strings? They're strings. Then result ij equals 1. These should be strings. Is that it? And then return result. Okay. Alright, cool. Six. Tablet doesn't seem to have power. Okay. Contemporary work of art that depicts the victims of the Justinian pandemic. Location. Alright. Got a code there. Sequence of numbers. Okay. And then over here. Circuit diagram. Oh, it's a Boolean system. The 3 wires of this circuit have been torn off. You have to choose where to plug them in to make the laser work again. The integrated circuit has AND, OR, and XOR, logic connectors. Alright. Wait, what? Three wires of this circuit have been torn off. Oh, so we choose 3 of these wires to make the final line 1. So either we do this with coding, or just do this by inspection. I mean, coding is not too hard. It just... So it'll be 8 choose 3. Which is 56. I think we could probably do it by inspection. Let's see, so... We have to make that line 1, we have to make that line 1. To make that line 1, either that line is 1 or that line is 1. Let's go with this one first. If we want this line 1, then these 2 have to be 1. 3 and... Either 1, 2, and 4. That will make that 1. But that would use up too many wires. Or just 3 and 4. 3 and 4 would work. So 3 and 4 would make that 1. And then to make the other one 1. This is XOR, so either... So if 7 was 1, then this line would also be 1. But that won't work, because that'll make this 0. So 7 must be 0. That's an absolute certainty. 7 must be 0. And that means 8 must be 1. And if 7 is 0... then that means this one must be 1. That means 4 must be 1. And 3 must be 1. So it's 3, 4, and 8? What did I say? Yeah, 3, 4, and 8. Okay. That's that done. You can aim the laser at 4 mirrors, numbered from 1 to 4 from the bottom left to the middle right. So, okay. We need a code for that. We've got this. We can aim the laser at mirrors. I'm not sure what we would do with that. No power. So let's try aiming the laser. 1. Are we trying to hit something? Turn this on. Okay, so that you just had to try a bunch of mirrors. This tablet allows you to control the lights in the museum. For that, one can send instructions by respecting its... Location ID, action, signature. Alright. So the location ID is that. Oh, we'll probably want code for this. What do you... Okay. Okay, so we've got the... Alright, can we move this down? So location ID is that. Action, I suppose, is... Oops. Where did we read this again? Okay. Lights. Do we want to turn them off? Probably. Alright, action is off. And then signature is the sum of all the letters in the location and action. Okay. So we say so let's say sig equals 0 for R in lock ID plus action. Sig plus, oh, hang on. If car dot is digit, sig plus equal the int value. If car dot is alpha, sig plus equal, so it would be ord of car minus ord of a plus 1, so that will make A1, B2, so on. And if it's hyphen or whatever, we don't add anything, and then return block ID plus okay, I don't know. Let's use I keep forgetting how to use F strings. I know you're supposed to use them. Still so used to whatever it was before F strings. Format. Okay. F. So it's look ID colon action / string sick. That looks a bit long, hang on. It doesn't have a fixed actually expected format. But what does that actually mean? Does it just mean it's the wrong value? Like if I just did that, they're saying is the correct format, just not the right value. Okay, so it's probably just not the right value. Okay. Well, do we want to turn it on? What are we trying to do here? Okay. That's the location. The only location we've got. That's just a code for the sequence of numbers. The action is either on or off, so there's only two to try. Let me make sure I copied the location ID correctly. Okay. Contained in the location of action. Let me. Which? It's not using the hyphens, is it? No, it's not. Okay. Let's test that I've got the signature correct. So, try on. Ockham and Cramet. Yeah, that's what I tried to begin with. So we can check if the signature is calculated correctly by using this example, assuming that this is a correct signature. I think so. So we can say that on 89. So the signature is being calculated correctly. It looks the same. What are we controlling? The lights. The lights of the museum, which I'm guessing we want to turn off. I assume the point is to see something. Turn it off. Let's print out all the characters and numbers. Huh. I saw the words each location, so maybe it needs to be split. Where does it say that? This might not be the right location. Oh, we want to turn the lights off the museum. And the location we have here is... This is the location of the work of art in front of us. Okay, so it should be The lights, those two lights right there. Can't do anything with this. We can't do anything with the laser anymore. Yeah, I could try summing these by hand and make sure that this is actually... Let's try just printing out what is going on here. Alright. So it's done. L12 992277. Oh, because that was 7 from before. Okay, fine. Just make sure. Do that. Okay. So L12 992277 K11 Q17 R18 I9. No, I think that's calculated correctly. Oh. Pretty sure we want to turn them off. So we've only got 3 groups here, and we've got like 5, but that's like a specific. You know, we removed. No. Try swapping to manual mode and typing 209. Well, just the signature. No, it has to be the string of characters which respects the protocols, so that's... I don't know why they call it action, because action is just that, what on or off. But they mean that. Do they? Like if I just... No. So, so we think the result is that. Let me just try typing that in. I have no idea. This is supposed to be easy escape room, so this I don't know, it must be something like maybe you're only supposed to use. No, and this one, simple digital code on which you enter a sequence of numbers. Oh, hang on, I think this is wired up wrong. This is going into that. Why has that happened? It's wired up wrong. That we were feeding that into the numpad and not into this, into the iPad. Do you want to turn it on? Okay, we wanted to turn it on. It wasn't very clear. They could have made that clearer, because like we're on the screen with the iPads. So, but it was wired to the other thing on the other screen. Oh, okay. Victim's sphere. The artwork has been turned on. You can analyze the state of all the lights. 1 for a light on, 0 for a light off. Let's have a look at this then. The big long string. Alright. Lights. And that is the location ID. Do we want to turn this into a code of numbers? That's all we've got left. So I guess this has to be turned into numbers. So if we grouped them like... I mean, is it just going to be binary? How many digits would you need for each number? 4. What? Oh, it depends. Well, yeah. Seems to always be starting with a 0, so... Wait. No, if that was... That's a that would be a 10, so... But the numpad only goes up to... Wait, why? Is this the same digital code? It's just when I click on it when I'm zoomed out. Yeah, I think it is. Oh, what's this? Oh no, that's the lights. I assume... Yeah, it's only 1 to 9, so that... But 9 would be 1, 0, 0, 1. But however I group them... If I group them in 4s... That wouldn't work. If I group them in 5s... Well, we've got big groups of 1s, so I don't think... Oh, is it unary? It's unary. Is it? Is it like 1, 1, 1? No. Well, there's a pattern going on here. We've got all these ones, and then we got this big sequence here. Alright, there's a bunch of repeats. What does that mean? How long is this print? Two, 3, 9, 4. And I mean, I assume we only want to type a few digits. We're not typing thousands in, are we? Two, 3, 9, 4. Or what if? Okay, let's try and print it like a square, because this is all in one row. Maybe it's... Yeah, that's what I'm thinking. We just need to know the width. 2, 3, 9, 4. Let me factorize it. Two, 3, 3. So like 18 by 133. Would it be it? You'd have thought they'd tell you this because we're looking at it. Okay. It seems a bit unbalanced. Oh, 133 is not prime. No, it is. No. It's not. Why have they... Yeah, that's the prime factorization. Why have they done it like that? That's not prime. Bloody Google AI. Two, 3, 7, 19. I mean, there's several different... Is it... It's not square. So I can try different ones, but surely there'll be... I mean, look, that's a sphere, so you'd have thought it'd be square. Let me have a look at this again. Wait, is 2394 actually the Alright. Let's try doesn't make any sense. There's several different rectangle widths we could do. I don't think... Although it has an output, so unless you can code, actually parsing the ASCII grid would look like the wrong path. Maybe. I mean, you can... I mean, sometimes you're expected to use manual if it makes more sense, but... feel like something would indicate what the size is, and that looks like it should be the same width and height. But then it clearly is describing a 2D grid because that's what it looks like. So yeah, I think the example they've given, what would that be? It's not really a rectangle. I mean, you could split it like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's prime. What? You can't. That's not even a. That's not even a rectangle. I mean, what else could it be? How many digits are there in ASCII? 8? This is not even divisible by 8. 7. It is divisible by 7. ASCII is 7, isn't it? Yeah, 7, because it's 8. An 8-bit code would have 7... No, it would be 8 digits. Well, it's not divisible by 8, so we can't just turn it into ASCII characters. Extra help with digital codes. Not yet. Down here you've got a picture of the lights, so clearly you're supposed to use the lights for this. And why have we got these patterns? Like, if it was an ASCII drawing, you wouldn't have these patterns. They don't really... Let's try printing some rows or something. Does it just repeat itself? I mean, is the whole thing just one repeating sequence? So like... Looks like it could be, yeah. So we got this. 1, 1, 1, and then you got some ones there. Yeah, you do. It is just repeating itself. Okay. Let's try and find the... Looks like it goes to about there. What does that mean? Alright, let's try and find the exact period. Let's use code. For n in range or to, I don't know, 1,000 for now. If lights from the start up to n is the same as lights from n up to 2n, print n for now. Yeah. Okay, these are all multiples of 126. Okay. All right. So what? Let's say it's 126. Okay. Let's take 126. For k in range. Yeah, it is clearly repeating. So maybe we only care about like one of these. It doesn't divide evenly. What does the final bit look like? It probably doesn't matter. Why would they do that and then let's just print what the final bit looks like. So print lights. So it's gonna be minus. Let's use some variables here. We've got n equals length of lights. So it'd be minus n modulo 126. That gives us the remainder to the end. Oh no, that's minus n modulo, minus this whole thing. Oh, hang on. Print n modulo 126. 0. Wait. 126. Oh, it is divisible by 126. 2337. Okay, okay, fine. So there's 19 rows that are the same, and this is what. Okay, fine. That's what we know about this so far. Get rid of that. Get that. Are they definitely the same? Let's verify that. So s equals set. Okay. S dot add that. Now print s. This will remove all duplicates. Can't really see from that. Print length 1. Okay, so they are the same. Fine. And there's 19 of them. So now I'll just look at the first row. This seems quite complex for something that was marked as easy. So... Okay. 1 through 6. Just have a look at this again. That's what we got. 0, 1. What the fuck? Two, 3, 3, 7. Morse. Well, does it for digits? Is it variable length? Groups of 5. This isn't divisible by 5. Divisible by again. It's what? 2, 3, 3, and 7. Divisible by 9, except there's 10 digits, so you wouldn't just use a unary system. I meant like including letters, you have 2 to 5. Oh. Oh god, yeah, no, it's... Morse without pauses is a real pain to decipher. Barely doable with code. It doesn't even seem like a good system. Like, if you wanted something foolproof and unambiguous, you would want, like, fixed length sequences, surely. That way... But then the problem is if you're transmitting something in like an SOS signal or something and some of the message gets cut out, then they don't know what part of the sequence they're in. So I suppose... But that's going to be a problem no matter what. I don't know, I've never fully understood why Morse code is the standard, because it seems like it's actually Because it's not two symbols, is there? There's three symbols. There's dot, dash, and pause, and the pauses are very important. So when you don't have the pauses, it's actually a nightmare to decipher what the message is. But then that's really ambiguous, because what is a pause? How long is a pause until it's pause? What if the person's like broken his wrist and is struggling to actually press the thing, and sometimes accidentally uses pause? Anyway, I don't think it would be Morse. Keep talking, no one exposed. Identifying pauses sucks. Yeah, it's... I guess it was developed for a specific usage, but the most general case usage where you just want to transmit a message doesn't seem like a good system to me. I would just transmit ASCII 8 bits at a time. There's no way it can be ambiguous. ASCII will be easier to memorize as well, because B is just A plus 1, C is just B plus 1, and so on. I've no idea now. I can't think of anything else. You can group it into 7s, 19s. Wait, oh no. 19 was the number. Why have we got this 19 times? So, despite what that picture looks like, it's actually like a barcode. We don't have to decipher a barcode, do we? Because I have no idea how we'd even do that. Let's look up barcode. What are the specifications of a barcode? How many? I don't care about the millimeters, I care about the... I don't even know how barcode works. Columns... it's not going to be a barcode, but I mean, it looks like a barcode because that's if you print the rows. Morse code was 1830, so true. But I mean, they had already sussed out a lot of key cryptography back then. I mean, they already even knew all this stuff back in the ancient Greeks times and the ancient Arabs. They knew how to do efficient coding systems. Should we take a hint? I've not taken a hint so far, but this doesn't make any sense to me. Can't see how this will be marked as an easy problem. Wait, it did say... What exactly did it say? It said easy coding, easy... Go to the menu. It wasn't for cryptography, they just saw it as an efficient message relay. Yeah, no, I can see why it's useful for what was it called? Those things where you go before we had phones. Telegrams. Because telegraph, yeah. because telegraph operators would be trained in this, and there's no loss of signal and stuff. Using it for SOS messages and stuff like that seems to be the problem. I guess they just went with Morse code because it was already established as the form of communication for telegraphs. But the problem is, you know, people who need their souls saving are not telegraph operators. That's the key problem, I guess. What did it say? It said search easy, code easy, logical medium. I mean, it could be like, there's so many just like solo ones and solo zeros, so I don't think it's like widths of the columns. And if it was widths of the columns, would we go with the zeros or the ones? And why do we have a group of ones here? I mean, and then we have a group of zeros here. So I don't think it's that, unless the zeros and ones are irrelevant and it's actually just width. So it'd be like 1, 1, 3, 1, 2, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. No, that doesn't make sense. Technically, I mean, I haven't even tried anything. I haven't tried inputting anything. Do we know if there's a limit on enter a sequence of numbers? I mean, we're not going to just insert this binary sequence, are we? Let's just do it and get it out of the way. No, it's not the... Just put something in. Okay. Easy might just make it logically the length of the pattern. Or what will be the sequence of numbers we input? One, two, six. Alright. 6. No. There's just too many obscure things I could do, but I don't want to do anything unless it's actually, there's some sort of clear indications. Wait, no, we want lights. No. Like that. Put it into 6s. No, there's no point doing that. 1, 2, 3, 5, 6. That's already like a more than 9. Let's take a hint then. All it does is add 1 minute to your score if you're doing this in a competition. Bottom icon of the digital code is a reminder of one of the objects in the room. We got that already. You have to count the number of lights on the sphere. Okay, let's do that. And is the count just gonna be it? Like there's... I mean, if that's the answer, there's no indication that it would be that other than a million different other things we could have done. Print lights dot count 1. One, 2, 1, 6. It's just the number of lights that were on in the whole thing. Why did they have a repeating row? What was the point in that? Because that wouldn't look like what we see there. It would be columns, which would look really weird. And like there was, I would have done that if it wasn't repeating, because the repeating clearly implied something. Laziness. That's strange because yeah, I've not seen them do anything like that before in any of these puzzles, like just repeating a sequence. But they usually took the trouble, like in the Sherlock one, they had like the dictionary and everything, a whole bunch of words in it. Oh well. But yeah, the repeating sequence completely threw me off. Once we found it was prime, we should have been looking for a simpler solution. Well, I think the problem really was that it didn't match up with the picture, because you're supposed to use the picture in your reasoning sometimes, and sometimes it's actually quite key. Even if the data in the picture doesn't match the format, sometimes, like in the Sherlock one, clearly we had to use what we saw in the picture sometimes. So the fact that we saw a bunch of lights that look like noise in a grid which looks like it should have the same height and width, it just didn't. It didn't actually match that picture. That was terrible. Not likely to recommend Coding Escape. I am likely to recommend Coding Escape, but not this one. Okay, let's hope. I don't know if it's the same, like, who makes these, if it's the same creator as the Sherlock ones. I don't think so. I guess they might have different authors for different ones. Well, let's move on to Castel Sant'Angelo office. So this is apparently the same difficulty. One second, I'll be right back. Okay. All right. Here we go. We're in. Look, we've got the painting. We might have to. There's like pairs of matching things. Okay. Interesting. That looks. Like we have to apply this painting to these things. Hello DIJ, how goes the coding? The last puzzle we did, the last escape room we did was going okay up until the last puzzle. The last puzzle was just really stupid. And the biggest problem was that the format of the data didn't really match what it looked like in the picture, so that really threw us off. It was a badly written puzzle. Let's have a look at the other stuff before I move to these shapes. We've got a clock. Okay, got a 24-hour clock. Fine. Bookshelf with 9 rows and 9 compartments per row. And choose which compartments to push. Okay. Carpet made out of different shapes. It is broken down into 81 cells 9 by 9, each showing 2 shapes. Fine, so we got 9 by 9 with a bunch of shapes. And over here, some times. We've got some sort of some sort of codes. Up here we've got a map of offices. Ah, okay, right. So it goes from 8 AM to 6 PM for each date. And we've got a letter. So What are these? Wait, so date is month, month, day, day. Okay. So here we've got dates and things that are done on those dates. Okay. And then we've got the computer. Password. I'm sure he wrote it down somewhere. Keep a lookout. He might have just written it on a piece of paper or something. Could be... Alright. Alright, let's start with... It looks like this thing can be done. Three statues composed of shapes. 3 angles. What? Angles. Rotated what? Like... So the shapes, the individual shapes get rotated? Or like the whole statue gets rotated round? Well, it looks like the shape rotation matches on them, so that's not... Probably not the shape rotation. So... Why would we... Let's try rotating it. Could it be... Fine, I'm not sure what to do with that. That's 9 by 9. And we also had... This is 9 by 9. Interesting. So... Wait, what? Each shows 2 shapes. The stands are the same color as the hands. Yeah. So, I was thinking it could be something like... We're gonna make... It could just be the angle of the hand, I suppose. Hang on, so that's 90, so... Okay. So are these angles 15 degrees? Yeah. So is it okay, so if it was okay, so green would be green is at, if we assume 0 and go clockwise, green is at 105. Hang on, so which order do we want them? The left statue to the right one. Blue, green, yellow. So blue, yeah, so green was 105. We want to give it as a float, really? Okay. Blue is 300. And yellow 225. Okay, that did something. All right, that's solved that. I don't know what the consequence was. Okay. Alright, I'm not sure what to do with this. So I assume we don't need these stands anymore. Or maybe visually we need them? Like, is there a reason we can see triangle, then square, then... I don't know. And then over here we've got this. We have a book of dates and times. So for every date and time, we have a letter. Here we've got dates but no times. And we've got shapes associated with them as well. So, painting in the carpet. Well, it's 9 by 9, and each cell has 2 shapes. I think the carpet is linked to the bookcase because they're both 9 by 9. In the bookcase, we want to know which books to push. Would it be... Oh, these could be times if each shape... Well, shapes appear multiple times and in different colors. I don't know. If it was like every time the 2 shapes are the same, then you push the book, like square, square. Like, how often... I suppose I could try that, but it's a bit random. Let's try it. So... list string. The string is gonna look like that. Okay. Turn. Yeah, so okay, so that's all false. And then for I in range 9, for J in range 9, left, right equals, so it's going to be lines, I, J, and then split on the hyphen. If L equals R, then set the corresponding book to be true. Then return that array. Nothing happened. Okay, so we got trues. True, true, true. Right. How could we get a true false out of this somehow? We're given two shapes. Do we have something which connects them as either a true or a false value? How are they defining the trapezoid? It's not on there. So on here we've just got square, rectangle, quarter circle, half circle, and triangle. Well, this is, I guess, different from the carpet. So the carpet... Oh, it is on... Yeah, you're right. It is on the carpet. Huh. At least in the picture. Let's print it out and make sure that... No, okay, so there's no... I don't know why they chose S for the circle. Okay, so there's no trapezium or trapezoid in America in the data, even though it's in the sphere. Well, strange to describe it as a sphere. Are they combinations? Well, most of these shapes don't combine in any meaningful way. And I don't think it even looks like a square plus a triangle. I mean, it could be a rectangle, but that rectangle would be really long and thin. It wouldn't even be the same. No, I don't think any of these really combine. Other than, like, I don't know, square and square makes rectangle. I think the picture is just misleading. I think it's actually just has these shapes. There's 5 shapes, but in here there's more. 1, 2, 3, 4, 5, 6. Okay, so there's the trapezium is an extra, and then we've got times. Here we've got a whole bunch of things. We've got a hand, an hour or minute, a color, and a shape. So all of those could be used together, probably with this stuff down here. We've got these as well. E12, E13. Those aren't referenced anywhere. Okay, this book. Maybe we should have a look at the book. On each date, wait, it's a list of dictionaries? What? Oh. Okay. Okay, fine. The intent just delete. All right. So for every date and time, oh. How many dates do we have? A lot of dates. Okay. And the times run from 8 a.m. to... Okay. So, a time from the clock corresponds to, like, a shape and even a color. So we can sort of tie a shape and a color to a letter. Ah, okay. So For each of these, we've got a date, and we can extract the time by looking at the shape. Okay, let's try that. Make a note here. So start from the top. Do we count the red one as being a top? So, hang on. So date equals 0212. Time equals, let's just leave that blank for now. So if we were given a date and a time, then what's the format of the, okay, let's just do time, 8 o'clock for now. Then let's look up the letter for that. So you'd say times I see. That's a bit confusing. All right. Okay. We'll just have to do a big old chunky for loop then. For page in times. If for time in times. No. A page in times. A page is a dictionary. If page date equals the date we're looking for, then and the time, okay. Then print page, what was it we want? Letter, okay. All right, let's just test this out. Oh, you need a colon for the time. X. All right. So let's start with 212. So it's a red square. Red square is so that's 12 o'clock. A. All right. And then the trapezium is 1:15. Time is a yellow trapezium. Orangey. Okay, that one. So that's 12, 13, 14. P. I'm not sure what order we should be going. Okay, we'll go square, trapezium, then this one, just by the height of the date. Alright, otherwise we can switch them around. 4, 24, so green half circle. Green half circles, that's 17. B. And then this one, I think this isn't the right order, but let's just get all the letters out. Time, so it's a yellow triangle. L. And then we've got the blue triangle. Night visit? Oh, it's not really in the night, is it? Alright, 9, 29. Blue triangle. Uh, 11, 10, 9, 8. Yeah. Oh. Apple blow. Okay, it's the wrong order. What does that spell if we mix things around a bit? Pablo. We went swap the first two. P-A-B-L-O. Pablo is a name. But why would it be like that? Why would you go this? Otherwise it'll be P-A-L-B-O. Pablo. Let's try Pablo. Pablo is as in Picasso. Oh, maybe. Okay, Pablo is the right answer. I don't understand why that was the order. So it was trapezium, then it was the red square, then it was the circle, then... Alright, fine. So that is the book done with. We don't have to mess around with the book anymore. Used to manage electrical devices throughout the building. If you enter a room ID, it will give you the list of available devices. If you enter device ID, it will turn on or off the device. Where have I seen this before? Oh. This is a list of rooms. Which room are we in? Has like an angled wall, so it could be this. No, probably this one. E14 1750. Yeah, I think that's it, because it has this little section of wall here. E14 1750. Those are the devices. Paste these here. Just try turning them all off then. Let me just copy that. Okay, let's try turning that off. Don't turn the computer off. Nothing happened, okay. Do we have anything that indicates that... Interesting. And we've already moved those and they can no longer be moved. Ah. So that's pairing the square with the half circle. So in this, we just need to find the either square in the half circle or the other way around. Or maybe both. Alright. Maybe both are books that need pressing. So it's SQ, S2. Okay. We don't do this. So we say T equals minus if T is SQ S2 or T equals S2 SQ, oh, door open. We revealed a door. But was that it? What was behind the door? I don't think there's a sequel to this. Rate this particular mission. That was good. Better than the first one. First one, that last puzzle was just really badly written. Alright, I'll give it a 4. I don't really give out any 5s. So we've done Sherlock. Steamhouse I want to do again because that was a long time ago. So we've done those. Is that? Yeah, that's the only Castel Sant'Angelo. Okay, that's the end of the story of Castel de Sant'Angelo. Did we manage to cure the pandemic that they were talking about? Who knows? We found our way into a room and that was it. I feel like they probably actually made a sequel at some time because I remember they used to have a paid subscription and you had some more puzzles, but it looks like they don't have those anymore. So I guess next time we do Huateca Collapse. Oh, this continues the story. But they could have made it clear. They could have used the same name. So this is the sequel. It's a bit longer, so that could be a whole stream next time. Medium, hard, easy. Easy, easy, hard. Interesting. So yeah, there's just the Steam House and Aquateca Collapse and the Curse of the Five Warriors. I want to do again. I remember this one being quite... The Curse of the Five Warriors was quite an involved one. This is the hardest one. But this was a live competition when this one launched. In fact, it probably shows my stats. Rank 54. I was doing it solo, and it was meant to be a group thing. Oh, only 2.5 hours. I thought it might take me longer. I mean, maybe that just goes to show too many cooks spoil the broth. Maybe these are best done solo, despite them forcing you to add another user to the team before you're allowed to participate in these puzzles. I think a lot of these cases it would actually just be easier solo. Like trying to coordinate with people like in puzzles where you need to kind of connect two different things together. I don't think it's really as much of a team activity as like those actual escape rooms are. This one seems more of a solo thing where you just need to keep track of what things connect together, because you can't have someone look at one thing and you look at another thing and then connect the dots, can you? You have to be the one that saw both things to connect them. Yeah, I don't think it's it certainly works in a team, but I think it works perfectly well solo and possibly even better solo. But they force you to add someone to the team, so I had to make a fake account for that. Yeah, okay. That's it then. Um, just taking a quick look. Is anyone doing CodinGame? I beat the average time by almost 20 minutes. Yeah, that's what I'm thinking. Maybe it's just better to do them solo. Like I think in team activities, people just get in each other's way, or they just don't notice that two puzzles are related or something. Yeah, solo is the way to go. No, just me as always. All right. Next time I'll be back with the continuation of this topical pandemic puzzle thing that they launched in 2020. So clearly they were just trying to capitalize on the interest in pandemics at the time. Just like the actual game Pandemic, the board game became extremely popular. All right. That's it. See you next time.